According to the 2002 National Electrical Code, a bathroom ground fault circuit interrupter, or GFCI, does not require a dedicated circuit. However, the code does require that it be on a circuit that is protected by a GFCI. NEC 2002, Article 210.11c3 addresses protection other than ground fault circuit interrupters. It states that bathrooms, laundry areas, and other locations as required by 210.8 or 210.8b shall have all 125-volt, single-phase, 15 and 20 amp receptacles protected by a ground fault circuit interrupter. The ground fault circuit interrupter shall be installed in a readily accessible location. Let's break down what this means. Firstly, it's important to understand what a GFCI is and why it's required in bathrooms. A GFCI is a device designed to protect people from electrical shock. It works by monitoring the current flowing into and out of a circuit. If there's a difference of even a few milliamps, indicating that current is leaking somewhere, possibly through a person, the GFCI trips and quickly cuts off the power. Bathrooms are considered high-risk areas for electrical shock because of the presence of water. Water is an excellent conductor of electricity, so any electrical fault in a bathroom poses a significant hazard. This is why the NEC mandates GFCI protection for receptacles in bathrooms. Secondly, the code specifies 125-volt single-phase, 15 and 20 amp receptacles. This covers the standard electrical outlets you typically find in a home. The voltage and amperage ratings are important because they define the types of receptacles that require GFCI protection. Higher voltage or amperage circuits are treated differently under the code. Thirdly, the requirement for GFCI protection does not automatically mean a dedicated circuit is necessary. A dedicated circuit is one that serves only a single appliance or a specific set of receptacles. While a dedicated circuit might be beneficial in some cases, for example, to prevent overloading a circuit with multiple appliances, the NEC doesn't mandate it solely for GFCI protection in bathrooms. What matters most is that the receptacles are protected by a GFCI. Fourthly, the GFCI must be installed in a readily accessible location. This means it should be easily reachable without having to use tools or move obstacles. Common locations for GFCIs include the receptacle itself, a nearby circuit breaker, or a dedicated GFCI device installed in a convenient spot. Consider a scenario where a bathroom has two receptacles. Both receptacles need to be GFCI protected. This can be achieved in a few ways. One way is to install a GFCI receptacle as the first receptacle in the circuit. This GFCI receptacle not only protects itself, but also protects any downstream receptacles on the same circuit. Another option is to use a GFCI circuit breaker in the electrical panel. This breaker protects the entire circuit, including all receptacles connected to it. A third option involves using individual GFCI receptacles for each of the two locations. Each approach ensures that the receptacles are GFCI protected, satisfying the NEC requirement, but none of these require the bathroom receptacles to be on their own dedicated circuit, as long as they are protected by the GFCI device. When planning electrical work in a bathroom, it's essential to understand these code requirements to ensure safety and compliance. It's also a good practice to consult with a qualified electrician to ensure that the work is done correctly and safely. The NEC is updated regularly, so it's crucial to refer to the latest edition for the most current requirements. While the 2002 NEC does not require a dedicated circuit for a bathroom GFCI, local codes or specific installation requirements might differ. For example, local amendments to the NEC are permitted and sometimes exist. These amendments can impose stricter requirements than the national code. Therefore, it's crucial to check with local authorities or a licensed electrician to ensure compliance with all applicable regulations. Also, the electrical load on a circuit must be considered. Even if the NEC doesn't mandate a dedicated circuit, it might be practical to install one if the existing circuit is already heavily loaded. Overloading a circuit can lead to trip breakers, overheating, and potentially dangerous situations. The total load on a circuit is determined by adding up the wattage of all the devices connected to it. This load must not exceed the circuit's capacity, which is determined by its amperage rating and voltage. For example, a 15 amp 120 volt circuit has a capacity of 1800 watts, calculated as 15 amps times 120 volts. A 20 amp 120 volt circuit has a capacity of 2400 watts. If the total load on a circuit is approaching its capacity, it's best to install a dedicated circuit for the bathroom receptacles to avoid overloading the existing circuit. Another factor to consider is the presence of other high-demand appliances in the bathroom, such as hair dryers or curling irons. These appliances can draw a significant amount of current, especially when used simultaneously. If these appliances are frequently used, a dedicated circuit might be necessary to prevent nuisance tripping of the circuit breaker. In summary, while the 2002 NEC does not explicitly require a dedicated circuit for bathroom GFCIs, it's essential to consider the overall electrical load, the presence of other high-demand appliances, and any local code requirements. GFCI protection is mandatory for bathroom receptacles, and the GFCI device must be readily accessible. Consulting with a qualified electrician is always recommended to ensure that the electrical work is safe, compliant, and meets the specific needs of the situation. Consider that older homes often have electrical systems that don't meet current code requirements. These systems may have limited circuit capacity or lack proper grounding. Upgrading the electrical system might be necessary to ensure safe and reliable operation of bathroom appliances and to comply with current NEC standards. This upgrade could include adding dedicated circuits, upgrading the service panel, and improving the grounding system. Also, consider the impact of adding new electrical loads to an existing system. This can affect the overall performance and safety of the electrical system. A professional assessment of the electrical system is recommended to determine its capacity and identify any potential issues. Furthermore, the type of wiring used in a home can affect the electrical system's capacity and safety. Older homes might have aluminum wiring, which has a higher resistance than copper wiring. This can lead to overheating and potentially dangerous situations. Replacing aluminum wiring with copper wiring is a significant upgrade that can improve the safety and reliability of the electrical system. Another important aspect is proper grounding. A properly grounded electrical system provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. Older homes might have inadequate grounding systems, which can increase the risk of electrical shock. Upgrading the grounding system is essential for ensuring electrical safety. Consider also the importance of regular electrical inspections. Regular inspections can identify potential problems before they become major hazards. A qualified electrician can inspect the wiring, grounding system, and other components of the electrical system to ensure that they are in good condition and meet current safety standards. During an inspection, the electrician can also identify any code violations or areas that need improvement. This information can be used to develop a plan for upgrading the electrical system to ensure safety and compliance. In addition to the NEC, other standards and regulations might apply to electrical work in bathrooms. These standards can cover topics such as wiring methods, grounding, and overcurrent protection. It's important to be familiar with all applicable standards and regulations to ensure that the electrical work is done correctly and safely. Remember that electrical work can be dangerous if it's not done properly. It's always best to hire a qualified electrician to perform electrical work, especially in bathrooms where water is present. A qualified electrician has the knowledge, skills, and experience to do the work safely and correctly. They can also ensure that the work complies with all applicable codes and standards. When hiring an electrician, be sure to check their credentials and references. Make sure they are licensed and insured. Also, ask them about their experience with bathroom electrical work and their knowledge of the NEC. Get a written estimate of the cost of the work before it begins. This estimate should include the cost of materials and labor. Also, be sure to get a permit for the electrical work if required by local regulations. A permit ensures that the work will be inspected by a qualified inspector to ensure that it meets code requirements. Following these guidelines can help ensure that the electrical work in your bathroom is safe, compliant, and meets your specific needs. The key takeaway is that while a dedicated circuit is not mandated for a bathroom GFCI under the 2002 NEC, the GFCI protection itself is essential for safety, and careful consideration should be given to the overall electrical load and local code requirements. It is always prudent to consult with a qualified electrician to ensure all work is performed safely and in compliance with all applicable codes. It is also important to keep in mind that there may be circumstances not outlined in the NEC that may affect your particular install. For instance, if there is a hot tub in the bathroom that exceeds a certain amperage or other large draw appliance, it may be prudent to install a dedicated circuit as a way to mitigate unexpected circuit breaker malfunctions. Keep in mind the NEC is a good reference point, but it is not an exhaustive compendium of all possible conditions, configurations or solutions. As such, it is up to the installer and the electrical inspector to determine whether it is suitable. The requirement for readily accessible GFCIs is to ensure that they can be easily tested and reset. GFCIs should be tested regularly, typically once a month, to ensure that they are functioning properly. The test is simple, usually involving pressing a test button on the GFCI device. If the GFCI trips, it can be reset by pressing the reset button. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. A malfunctioning GFCI can provide a false sense of security and may not protect against electrical shock. Also consider tampering with electrical devices can have serious consequences. Only qualified persons should perform electrical work. If you are not familiar with electrical codes and safety procedures, do not attempt to do the work yourself. Hire a qualified electrician to ensure that the work is done safely and correctly. Consider that advancements in technology have led to the development of new types of GFCIs and other electrical safety devices. These devices offer improved protection against electrical shock and other electrical hazards. Staying up to date on the latest electrical safety technologies can help ensure that your home is as safe as possible. One example is arc fault circuit interrupters, or RFCIs, which protect against fires caused by electrical arcs. RFCIs are now required in many areas of the home, in addition to GFCIs. The combination of GFCIs and RFCIs provides comprehensive protection against electrical shock and fire hazards. Another example is surge protectors, which protect electronic devices from damage caused by power surges. Power surges can occur due to lightning strikes or other electrical disturbances. Surge protectors can help prevent damage to sensitive electronic equipment, such as computers, televisions, and appliances. Consider that the NEC is a living document that is updated every 3 years. These updates reflect changes in technology, safety standards, and industry best practices. Staying informed about the latest NEC requirements can help ensure that your electrical system is up to date and compliant. The NEC is developed by the National Fire Protection Association, or NFPA. The NFPA is a non-profit organization that develops codes and standards related to fire safety and electrical safety. The NEC is widely adopted by state and local jurisdictions throughout the United States. In addition to the NEC, other organizations develop standards related to electrical safety. These organizations include the Underwriters Laboratories, or ALL, and the American National Standards Institute, or ANSI. UL standards are used to test and certify electrical products. ANSI standards cover a wide range of topics, including electrical safety, and provide guidance on best practices. Considering all these factors ensures a comprehensive understanding of bathroom GFCI requirements and electrical safety in general.